All right. Starting my office hours. Just verify real quick that the audio is good. Um, the chat says it sounds good. That's a good sign. And eventually my phone will make sound if it works. The chat says it's all right. That is quite the delay, but we'll work with it. Okay, so welcome to my office hours this week. We're going to be going over Baby Race again, like my last office hours. Um, uh, yeah, let's just jump straight into it. Are there any immediate questions surrounding Baby Race? Okay, so I'm seeing someone asking about the first TCP level, level 8. There's a question that I can quickly address. Is 9, 10, and 11 supposed to be the same? So these levels are new this year, 9, 10, and 11, and the goal of them is to prepare you for Toddler 2. And in particular, level 11 is very crucial to, I don't know, that race condition in level 11 is like the premise of a race condition that exists in like half the Toddler 2 levels that interacts with a heap. You'll see eventually in Toddler 2, but basically that race condition interacts with the ability to cause a double free in Toddler 2 and blah, 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 blah. So we added it this year to make sure that people actually understood the race itself before jumping into Toddler 2. So I guess to give some spoiler to it, we kind of expected that your solution for 10 and 11 would almost certainly be the same. That's just the fact of the matter. The goal with level 11 is to kind of expand upon 10, and the hope is that you'll notice kind of the difference in the program itself, and you'll notice, hey, this race condition still works, and maybe you'll think about why does it still work. Unfortunately, it's not like a challenge that directly requires you to come up with a new solution. It is kind of, we're hoping you'll kind of think about, hey, there's a difference between 10 and 11. My solution still works. Why does it still work? Yeah. And then it turns out while we were designing the challenges, we found this race condition and we kind of introduced two race conditions and we weren't exactly sure which race condition people would run into first. It seems like a lot of people are running into the level 10 race condition before they run into the level 9 race condition. And that's why your solution ends up working for all three. It also turns out that you can design a solution to the 9 only race condition, and that solution will end up also working for 10 and 11, depending on how you set it up. Little unfortunate with how that kind of is designed. Potentially, maybe next year we'll get rid of 9. I'm not really sure. To think about that. I guess it kind of takes you from no semaphores to semaphores, at least at the minimum. But yeah, that's kind of the idea. There is some unfortunate artifacts with those later race levels where it kind of honestly ends up being pretty easy to solve those levels. And more of the challenge is in kind of expecting you to really understand what's going on rather than some of the heap levels or memory or ROP where you really have to think for a while to design your solution. You can kind of, in some sense, you can guess your way into the solution for some of these race levels. But that's just how it is. Yeah, so someone's asking, we're talking about 9, 10, 11. Yeah, that's just kind of a description of 9, 10, and 11 at a high level. Yeah, so I mean, I would recommend anyone that's solved 9, 10, and 11 to just make sure they understand what they're racing against and how that actually works. Yeah, so it's, yeah. Okay, so what else is going on in chat? I guess there's several messages. So someone is interested in 6. I'm seeing, could you go over 4? I'm having trouble finding how much to overwrite. I tried using pwn.cyclic, but the same method doesn't seem to work to get the number. Does 4 have the win variable, or is that 3? The hope is you'll be able to use the exact same techniques from baby mem for figuring out some of those details. The same using cyclic wouldn't work. I'm going to assume that that's the win function level. Cyclic doesn't work. I mean, eventually you should get a core dump. You'll have to make sure that if you're using pwn tools to run the process, that you're doing setUID equals false so that a core dump can be generated. But otherwise, I mean, eventually, once you win the race, you'd get a core dump, assuming your pwn.cyclic is long enough. And once you get that core dump, you should be able to do the exact same thing as baby mem stuff to get the offset. Yeah, so are you having an issue generating a core dump, Jupiter? Do you mean like pwn gdb debug? Yeah, hopefully you should be able to use the same techniques. I'm not sure if you're having an issue getting a core dump. Yeah, you might need to mess around with it more. Yeah, it should be the exact same kind of techniques as baby mem. Okay, someone gave you some ideas. Awesome. Okay. So people talking about Yawn 85, finishing out some challenges to get their yellow belt. Okay, so going back to levels. So someone is interested in 6, and they say that they don't know how to bypass the LStat check. So just to clarify, are you asking specifically about 6.0 or 6.1? As in, you don't completely understand how, given infinite time, how you could bypass these checks? Or is it a matter of getting the timing right to do it? And then, yeah, someone was curious about 9. And was someone curious about 8? Let's see. Okay. Someone asking about 8? I thought someone was. Why am I not? Oh, yeah, there it is. Okay. All right, let's take a quick look at 6.0. Don't know how to do 6.0 manually. Okay. That is something we can talk about. Okay, let's start 6.0. Okay, we are connected into 6.0. We run the challenge. We will see, as always, or as the previous levels, we're allowed to specify an argv1, and the contents of that file will be sent to you. So here are the requirements. The challenge will verify that the file's path does not include flag. That's standard. The file is not a symlink. That one is pretty standard. The challenge will verify that the directory the file is in is owned by root, and that other users are not able to create files in that directory. Okay. I'm not sure if there's more requirements or if this is just the main requirement. File is owned by root. the directory the file is in is owned by root, and that other users are not able to create files in that directory. Okay, so that would probably basically disclude the idea of temp, which is owned by root, but other users are able to create files in this directory. So temp would not work. So for instance, if we touch temp A, and we do, actually just to make sure in case it does pop out at us, let's put some contents in there. And if we run challenge this, temp A, we will see, okay, so this was the requirements. It says it's going to call lstat, does not follow symlinks. Okay, so this should be fine. We're not a symlink, so it's not going to be an issue. Calling lstat does not follow symlinks on the directory. So here it's going to call it on temp. And this is where it's probably going to be able to see that other users are able. So it's probably going to fail here if we hit enter. And it says error, other users are able to write in this directory. Okay. So on the other hand, if we pass it, let's say, so if we look at etc, which is different than /temp, how do we just get it on, can I do that? No. Rep. That's okay, good enough. So this directory, etc, is also owned by root, but other users are not able to create files in here. So if instead we pass it etc password, so etc password, and we hit enter, it's going to call lstat. Etc password is not a symlink, so that should be fine. And now it's going to call it on the directory, and here it should succeed. So it didn't complain, and then it's paused again. So it must be doing presumably 2 checks. Or no, maybe this, we'd have to look at the binary to be sure. Maybe we should have some debug information that says this. I think this last pause is before we send the contents of the file, I think. And there, yeah, okay. So that it's willing to, for instance, give us the contents of etc password. Is it only giving a certain amount? Is it only giving like 256 bytes? How many bytes is that? Yeah, because that is not the full contents, but it doesn't matter for us. Okay, so yeah, I can talk about 9, 10, and 11 after this again, just for anyone that's rejoined the chat. Okay, so this is, it's willing to give us etc password. Obviously, we want the flag, not etc password, but this shows the constraints, why we couldn't do temp A, but we could do etc password. The file is seen as owned by root. I'll use it. Okay, yeah. Okay, so here is something interesting to note about symlinks. And it's definitely not intuitive necessarily until you think about why this would be the case. So if I create some directory, let's just call it test in my home directory, and we go into test, and within test, I create a symlink, let's say A, which goes to /. We got that backwards. I always get it backwards. So now we have this directory, the symlink A, which is going to /. And we create this other directory, let's say, hold on, I'm trying to think about how we can do this. So we can't have flag also in it. Let's see. Though we could get past that. Right. So this points at /. And let's create a follow-on directory. Let's say B. So we have symlink A pointing to /. And then let's say that within B, we create a directory called etc. So what do we want to do? Yes. And then let's say within etc, we do echo test to password. So we're kind of setting up the structure that looks similar to the Etsy password structure. Okay. So, oops, ls-al. So for instance, now we can do ls-al a/etsy/password, and we're going to see this file, and we can do ls-al b/etsy password, and we're going to see this file. Okay. And something to note is that even though there is a symlink in this path, so if we do that, yeah. So like, we can see this path right here. We have this home hacker test a Etsy password path. And A is a symlink. But what isn't a symlink is password. Password is not a symlink here. This is an actual file. And even though A is a symlink and there's a symlink within this path hierarchy, password itself, this actual inode here, is not a symlink. Maybe inode isn't the correct word there. I'm not entirely sure. But either way, this file is not a symlink. So we can show that if we do challenge baby race level 6 and we pass it a Etsy password, we will see that it's calling lstat, which will not follow symlinks on the path. And if we press enter, it doesn't complain. It doesn't say, hey, you passed an a Etsy password and A was a symlink, therefore, oh, it's all a symlink. That's not true. Password is not a symlink. All that matters is that terminal node in the path hierarchy. That terminal node, if that is a symlink, that's what it's checking. This password part, if that is a symlink. And this probably isn't immediately intuitive. So I kind of, I guess, as a more information surrounding this idea, if we look at man to open and we look at some of the options here, you might be thinking, okay, well, how do I do security if I don't ever want to deal with symlinks? I want to verify that every part of that path is not a symlink. So one option, in theory, you might think, would be to basically just split this apart by slashes and walk through every part of the path hierarchy and check if every single part of that path hierarchy is a symlink. And you could do this, but as we've been working with race conditions, I'm sure you're aware that if we make a bunch of syscalls and walk every part of this path hierarchy and check if it's a symlink, you could race that. Maybe we should have a challenge on that, but that would not be necessarily a secure atomic way of checking to see that, hey, nothing in this path is a symlink. If you don't want to follow symlinks at all, though, and you want to do this kind of idea atomically, there is a way to do that. And it's this O no follow flag. So if you do O no follow, please talks about it more. If we open a path and we specify O no follow, it will, if path name is a symbolic link, then the open fails. Symbolic links in earlier components of, oh no, hold on, that's not true. This is not correct. Will still be followed. Note that the can still occur. Is it not oh no follow? Oh, I could have sworn it was oh no follow. File descriptor referring to the symbolic link. Is it really not oh no file or no follow? I like almost don't believe this. Am I reading this wrong? Is there a different one? Is it O direct? Nope. There is definitely a way to just absolutely not follow symlinks. I'm sure of it. used symlink follow. Maybe there isn't a way to do this, at least in this way. Oh no follow. Could have sworn we have something using oh no follow. Is that incorrectly assuming that behavior? Huh. Maybe you can't do this. Hold on, let's just test it. Emacs test.c int main open argv1 o read only o no follow. And what do we need? That is that the header? Let's see. Oh, oops. Seems to compile. If we do, guess we could just strace it. Etsy Etsy password. Strace that. No, it's opening it. Huh. What if we pass it a? Here it's complaining. Interesting. Okay, so there is another way to do it, and this is how we're doing it in the new kernel infrastructure. If we do dojo GitHub challenge setuid Python. This is going to be our new kernel infrastructure, and here's how we get around symlinks fooling us. We just call real path on the directory, and then we do all of our analysis on this real path. And real path is going to resolve symlinks, and then if you want to check properties about that, now you have a already followed through all the symlinks. Depending on your scenario, that is an option. Okay, enough of this tangent though. Okay, so back to solving 6.0. So there are ways to do this securely, but apparently it's not oh no follow. But either way, this challenge is not doing it securely. It's trying to make sure that there's not like a symlink, so we're not going to get fooled by symlinks. And we already showed that there are ways to introduce symlinks into the path hierarchy, and those will be followed. So if we run challenge a Etsy password, and we hit enter, calling lstat does not follow symlinks on the directory. Oh yeah, we already saw this. So that'll print out Etsy password. Okay, so what else is there? Oh, right, now we want to actually get the flag. So hopefully we see that with this kind of symlink trick that we're on the right path to doing this. If you haven't solved 6.0, it's very likely, I would assume, that this is the key insight that's missing. So how we can further exploit this. If we create... can we do this with 2 directories, or are we going to need a third? Let's try this. Okay, so if we remove password, and instead say that password is a symlink to flag, okay, so we have this thing going to /flag now, and let's open up tmux so that we can do manipulations on all of this as we run it. So if we go to this directory and this directory, and we run the challenge and we pass it, we need one more thing. We want a symlink that will allow us to go between A and B, so we'll call that C. So if we do ln AC, oh, not make dir. Okay, so now we have C pointing at A, and now we can swap C between A and B. So if we run challenge baby race C A password, that's not correct. C etsy password. Okay, so our first requirement is calling else that does not follow symlinks on the path. Okay, so currently Etsy password, this final node is actually pointing at the real Etsy password, which is not a symlink. So this should succeed. Okay, now we're going to call lstat on the directory. And this should also succeed, I believe, because Etsy is a directory which is not a symlink and is owned by root and is not writable by other users. And this is the real Etsy directory. Okay, that succeeds. And now we're about to send the contents. And of course, if just to show it real quick, if we press enter, it's going to give us Etsy password, but let's run through it again. We go through those two, and so now it's again about to send it to us. And if now what we do is we RMC and we link C to B, it seems that we're done with checks, so we're about to actually give the contents of the flag, which would be represented by C Etsy password. Oh boy, we did the wrong thing. Hold on. Always getting ln backwards. Okay, and if we look at C Etsy password, we will see that this is pointing at the flag. And if we hit enter, we will see out comes the flag. So that is kind of the key idea of 6, especially 6.0, is even though we're trying to avoid symlinks at all costs, all that is checking is when you call lstat on some file, it's only looking at that terminal node of that path hierarchy. If that is a symlink. It's not checking if there's a symlink encountered along the way. For some reason, you apparently can't use ohnofollow. I have to look into that after the office hours. I could have sworn there was a way to open without ever following a symlink, but cannot see it apparently in the man page. Okay, so that is 6. So okay, so there was another question again about 9, 10, and 11. Is there an intended sequence of solutions for 9, 10, and 11 that only worked on each level? So yeah, I previously covered that at the beginning of the office hours, but the long story short is that 11 is crucial to Toddler 2. It's going to be a pivotal part of like half of the challenges. That's why we added it this year, added 11. 10 and 11, we kind of expect or would not be surprised if your solution looks the same. It turns out, though, that a lot of people have 9, 10, and 11, all 3 of them, their solution looking the same. I would encourage anyone that's gone through 9, 10, and 11 and maybe just kind of got the solution and it was seemingly too easy or whatever, to just go through and understand why that race condition on all 3 of them worked. What are you actually racing? Yeah, what is the, try and more, I would recommend, and it'll help you with Toddler 2 to some extent, if you go through and really understand how that race is succeeding, rather than, I don't know, maybe some amount of people just tried the first thing that came to mind and suddenly they're getting the flag. Try and understand why that race is succeeding. Okay. And the differences between the 3 levels. Okay, so are there any more questions? I think someone was asking about 8. Were there any more questions on 6? And as I get ready to go into 8, if there's more questions on anything else. talk about the first TCP level 8. Okay, so the person asking about level 8, are you asking, I guess, about 8.0 or 8.1? Are you wondering about where the race is? Are you wondering about how to write code that will succeed? I guess that's kind of my question. What were we racing on that level? On 6 or what level? I'm talking about 6 you just did with Simulix. Oh, so on 6, the thing we were racing is, so we call lstat on the full path, and then we call lstat on the directory, so kind of going up one level in the whole path hierarchy, and then we send the content. So most likely, and since based on how we did it here in 6.0, it seemed like we only had to do one quick little swap. We made it so that these two succeeded, but in the way that they have to succeed, like there's no way, unless I'm missing something, that you can just have one path that's going to make it through all the checks and you never have to change anything. So the thing that we were racing was basically, and like a lot of these earlier levels, the thing that we're racing is, okay, get me through all of the checks, and then let me change out the file, and here's what you're going to actually send the contents of to me. So this is a classic race condition known as a time of check, time of use race condition. And yeah, as the name implies, the whole idea is you can squeeze between, and if it's incorrectly implemented, the time that a program checks constraints or requirements on something, and then after it does that, you can squeeze right in and change something out, and now at the time of use, you're going to basically have something that would have violated those constraints. Okay, so wondering mostly how to approach 8.0, and then there's also someone talking about how to make a socket interface that isn't janky. Okay, so let's look at that. You know, I should probably launch challenges in practice, because I don't actually care about the flag. Okay, so if we run the challenge, we are going to see that it presents us this information. So it says this challenge is listening for connections on TCP port 1337, something we've seen in prior challenges. And it says the challenge supports unlimited parallel connections. So this line here is actually different than prior connections that were accepting connections on TCP port 1337. And it's because the implementation is different. So in previous challenges that had this TCP server set up, the way that it would work is it would wait for some incoming connection, and as soon as it got a connection, it would call fork, and then the child would do some work, and then the parent would basically wait for the child to die. So this would be known as like a fork server. It's just using separate processes for being kind of the worker threads or worker constructs. I don't know. In this case, it's not using fork. It's not using processes as its workers. Instead, it's using threads. And as part of the implementation details of this, rather than only allowing a bunch of sequential connections, in this case, in this threaded environment, we allow unlimited parallel connections. So you can connect up in multiple connections at the same time. So let's look at that. If we launch tmux and we run the program and we netcat localhost 1337, we'll see we get this message. And if we netcat localhost 1337, we'll see we get this message. So in previous challenges where you could connect into port 1337, this second netcat session would have just been hanging until the first one died. But here we're connected up with multiple connections at the same time. And if we want to look at how this is implemented without, I guess, looking at the binary, we can look at the proc interface. And if we do ps-aux, and I guess it's a good thing I ran in practice mode so I can quickly, without having to restart how this is working, we can look that this is running on 116. And we'll see that there's only one thing that has this command of challenge baby race level 8, whereas in previous iterations that used fork, we would see 2 of these, one for the parent, one for the child. But somehow things are happening multi-threaded, and what happens here is that ps-aux is not showing us threads. I think there's a way. Can you do aux-t? We'll check real quick if there's a way to do this. Threads. Show threads. Let's try that. H. Okay, so we can see threads in this way. So here we can see all of these are process ID 116, and we have 3 of these things. We can't see a thread ID. Another way, though, to see this information is that if we do proc 116, oops, we are not typing correctly, 116, and just to show that this is our process, we can see here, challenge baby race level 8. And if we go into task, we can see these 3 threads that are running within this process. So we have one that's also 116. So if the thread ID is equal to the process ID, that's kind of the main thread. And then we have these other tasks or threads that have different thread IDs. 126 and 136 in this case. And then I guess just one more way to see this, that we have these threads without looking at the binary itself, is we could use Gdb. And this is, I guess, something you probably haven't seen yet. How to use Gdb with a threaded environment, which, as it turns out, is going to be very useful in Toddler 2, knowing how to do this. If we do sudo Gdb, and we do, oh, I don't want pwn debug. Emacs Gdb init. Okay, sudo Gdb. And if we do attach to 116, and we can do this because we're in practice mode, and well, there's a number of ways to be able to debug this process, but in practice mode, we're using sudo Gdb and attaching straight into this setuid binary. Alternatively, you can make it so the binary isn't setuid and attach in, or use pwn tools to make it so it doesn't run as setuid, all sorts of ways. And if we, now that we're attached, do info threads, we will see that there are, in fact, 3 threads. This first thread is kind of sitting blocked on libc accept, or the accept syscall, and then these next 2 are blocked on read syscalls, which makes sense because we have a prompt asking us for information, and probably it's waiting to see what are we going to give it. Okay. And just to show more info, you can do, for instance, thread 2, thread 3, thread 1 to switch between the threads. And if you set a breakpoint somewhere, and any of the threads reaches it, when Gdb interrupts itself on that breakpoint, it will switch into the context of the thread that hit that first. So that is kind of the idea of doing Gdb and threading. It's actually not too difficult. It's a little bit more annoying than just a single-threaded program, but it's not too bad. Okay. And someone said up to 120, I guess, so max con. Yeah, I don't remember. I can believe that it's up to 128. Though I'm not entirely sure on that. We'd have to look at IDA. Actually, and anyways, we're going to look at IDA. So let's do this SSH project CTF.college. Oh, that is not what we want. We want CD. Okay, and let's scp hacker at dojo.pwn.college. What do we want to scp? Challenge. And let's scp that here. Okay, so if we open this up in IDA, which is probably the correct thing to do considering how much information has been presented to us in the teaching helpful output. We don't really know where our race condition is, so we kind of need to do a little reversing of this program. And let's just go straight into decompilation. So the person was talking about up to 128. I think something here. I'm not totally sure where you're getting 128. It's definitely possible that it's up to 128, but D1, this opt name, don't remember how to do this. Because I don't remember the sorts of, I'd have to look at the source code. I don't know, doesn't matter. Okay, either way. So this is the challenge. We can see that this is how it's getting ready to set things up. Here's our while loop, and what happens is we accept a connection. I guess we malloc this thing, which is going to contain the file descriptor, which is the result of accept, which is going to be the file descriptor that the client connection is on. So let's just say client FB, and we malloc this thing and we store this information in it. Turns out this is just implementation details that don't super matter, but then we pthread create our new thread, and we basically specify, I guess, attribute. I'm not entirely sure. 0, it doesn't really matter. Then we say what this thread is going to kind of initialize on. So it's basically where code is going to start executing for this thread. And we have this function called run thread, and that's where it's going to end up. And we can pass it an argument, and this stuff is been malloced and passed as an argument. So if we jump to run thread, we can see this crazy decompilation, which doesn't super matter. Set vbuff. Ultimately, it's going to start calling challenge. So what's happening here and why the decompilation looks a little bit weird is, so we're taking that A1, so the very first thing that was being passed, which is this client file descriptor, which is going to be at the beginning of this argument thing, this argument struct. And we're doing an FD open on it, and we're opening it for reading, and we have another one that we're opening for writing, and we're storing it at this weird location, and where this weird location is in thread local storage. So similar to Tcache, how Tcache, or at least I guess not in the Tcache you've seen so far. So in the main thread, Tcache is storing all of its chunks in just kind of the global standard heap arena. But if you start spinning off more threads, it's going to start storing Tcache in thread local storage. And that's kind of what's going on here. We're storing these file pointers in thread local storage because we've opened these things and they're going to be specific to that thread. And then we set vbuff on it, which we've seen in main, set vbuff, where? Here, which ultimately is just disabling buffering, doesn't really matter. Oops. Okay, so we FD open these things, disable buffering. And then we jump into this challenge function, and this is where the functionality really starts to exist. And if we look here, just basically anytime you see this readfs keyword, all of this stuff is just pointing at that client file descriptor so that it can communicate with it. It has to be implemented in this way so that all of the threads are talking to their correct things, and for templating reasons, it's all whole thing. Okay, so if we do kind of some quick reverse engineering of this, we will see we have login, logout, win, auth, quit. So win, auth sounds cool. So probably the first thing we want to focus our reversing efforts on is how can I win? How can I get the flag? And maybe we work backwards from there. So we can see that within this win auth thing, there is a scenario that I'll call win, which is what we're looking for. But in order to do this, we have to pass these if conditions. So we have this privilege level thing. If not privilege level, go to label 11, which is probably a fail condition. So if privilege level is equal to 0, we're probably going to fail, though we could try to better understand this logic and see with this crazy structure of else ifs and go tos if maybe it isn't actually a fail, but probably it's a fail. Otherwise, if privilege level is equal to 1, it's going to tell us your privilege level is too low. And then otherwise, so basically if it's not 0, it's not 1. If it's anything else, we win. So that's cool. Okay. So how can we make our privilege level be something other than 0 or 1? So if we log in, we can see that privilege level ends up getting set to 1. Okay. If we log out, we can see that if privilege level is non-zero, we are going to drop 1 privilege level by doing this decrement here. Okay. And those are our options. So something to realize is that this privilege level thing is, can I double click on this? Where'd we go? Here. It's in the BSS, which means it is global data that it's kind of reasonable to expect that all threads are going to be willing to look at, and they're all looking at the same exact copy of this privilege level, which is different than, for instance, our client file descriptor, which is doing this crazy read fs keyword, this thing, to get at the client file pointer. And that is thread local storage data, which it's kind of expected that only a thread is going to be looking at this data. And then there's also the thread stack. So for instance, this result here and this S1 and this V2, this is all on the thread stack, and a thread has its own stack and other threads aren't. Most likely, and under reasonable operating conditions, going to be looking at other thread stacks. So this is kind of all private data. This is private data, but this privilege level thing is global data. So most likely since there's not a whole lot of functionality here, and this is the critical component, this is the thing that we're going to be racing around, most likely. And we can see also for more evidence of that we have these pause things happening right before we decrement a privilege level. And where else do we have a pause? Click here. So we're willing to pause right before privilege level becomes 1 and right before we decrement it. Those are our 2 locations for pausing. So race to double log out so that the privilege level is -1. That sounds like a very good idea. Yeah, there's, I mean, we're not looking at type information here. Privilege level. It says it's an int. This is what IDA is assuming, is that this is an int, which means it's the signed thing. So yeah, if we can somehow go from 1 to 0, and then 0 to -1, turns out the -1 is neither 0 or 1. That would be very good for being able to win. Yeah, so I'm not going to go directly, I'm not going to like write up a solution, but I think probably discussing this, yeah, it seems pretty clear kind of where this race is and how we can abuse it. Okay, so there's two follow-on sorts of questions surrounding this level. And one of them is understanding how to make a socket interface that isn't janky. And then another one saying how to increase the hit rate. I think I've been using Python wrong this whole time. Okay, so these are all good things to think about, and they're going to be incredibly... So if you think these race conditions have been maybe easier than previous modules, the unfortunate reality is with these race conditions that it seeming to realize is that in order to really create a complicated race condition, you really need a larger code base and more stuff at play. And that is going to happen in Toddler 2. So it is really important to understand things like how to increase hit rate and make things more likely to succeed and not do things incorrectly for your race condition, because let's just say in Toddler 2, when you have to win a race condition like 12 times back to back to back to back, and you're also having a terrible time trying to debug this stuff because the thing that you're racing is causing a use after free, and then there's memory corruption. It's all sorts of chaotic stuff. It becomes very important to understand these concepts. So if we, so something we can do to talk about this, if we, let's see here, do I want to switch to 9.1? Let me think here. So the issue is I don't really want to write a solution to 9.1 in this office hours. Let me think here. Okay, there's a couple of concepts that are useful to understand as we start writing a script. This. Okay. So if we import pwn, and then let's do with pwn.process, challenge, what? Tab complete for me, please. Yes, this next. Okay, sweet. With pwn.process of this, I guess we're on 8.0. Let's make it a little more realistic and look at 8.1, where we don't have these pauses that dramatically impact our timing. Okay. So let's do import pwn with pwn.process of the challenge, baby race as process, and then how to show this. Let's do with pwn.remotes localhost 1337 as remote. And let's just start by doing remote.readline pwn info that. Okay, so we can see it just tells us privilege level 0. So this is kind of a quick skeleton for getting ready to write this stuff. And then Another thing we can do just to kind of quickly test, though this is not going to be good for IPython, I think. So if we do os.fork, we would in theory get 2 connections. Yeah, IPython is not happy about that. Turns out that an interactive REPL doesn't suddenly like there to exist 2 clones of it interacting with the same TTY. Not a cool thing. Let's write a script then. Let's do history. Let's get rid of this. History. We will copy this. What's happening? Yes, I really want to exit. Okay, we are not allowed to exit. Oh, we are. Okay. Wait, what? Okay. Reset. Okay. If we do, let's just, I can't drag these around. Okay, we'll reopen these later if we need them. I don't think we need them, but maybe we will. Okay, so we have 2 connections. Basically, I'm trying to avoid tmux right now because it's easier to work with Emacs, not inside of tmux. And we do, I guess on this first one, we do Emacs x.py. And we paste this. Let's just make these tabs less crazy. Okay, and then if we do Python x.py, we see this. And now if we do, for some quick multi-processing in Python, we just call os.fork. Spawn Tool's not happy about this? Why? Okay, hold on. Let me try. How do I want to do this? I'm trying to think about where this might be failing. Process equals that os.fork here. Let's just not close it. Let's let the script close itself. Okay, cool. And we can see 2 copies of privilege level. So this is a quick way to get 2 instances of remotes. If we wanted 4, for instance, we could do this. Basically, every time you call os.fork, you're doing 2 to the number of forks as how many processes you're going to have, because we're just calling them consecutively like this in a crazy sort of way. So we have 4 privilege, privilege, privilege. Where's the 4th one? It's possible. This way of doing it might be too crazy. I'm thinking that one of these copies of pawn tools is probably exiting and then killing baby race level 8, which is unfortunate. Probably the correct thing to do would be to actually use concurrent.futures or whatever, multi-threading or multi-processing. All right, let's see real quick if we can use, I saw this being discussed as a less miserable way of doing multi-processing in Python. Is this the correct package? Concurrent dot, okay, import didn't care. Hold on, let's open IPython. Import concurrent dot futures, and then there's like a thread pool executor, and I think there's a process pool executor. Okay, let's try do something crazy here. So there's a question in chat, why can't you just do multiple pwn.remotes in sequence? So as part of this race condition, we're going to need 2 connections simultaneously talking to this server. And if we just did, for instance, like this back to back, like this followed by this, these are going to happen sequentially, but we're trying to create a skeleton for ourselves of a script that is going to allow multiple connections to start talking and interacting with the server all at the same time, because part of race conditions is you need these things happening concurrently rather than sequentially. So that's kind of why we're trying to create a skeleton script for ourselves that's going to allow us to do this in a way that isn't miserable. Okay, so with concurrent futures process pool executor, why do I not know how to auto, is it not tab? Oh, it's right. Okay. I think we call that, we can do max workers, none or not given than as many worker processes will be created as the machine has processors. Okay, so we're going to have more than enough capacity here. Though potentially we'd want more than the number of workers we have. So in theory, we might need to specify max workers, but probably not. Let's specify just to be safe. So let's do num connections equals 8, and let's just do num connections. Okay, and then I believe as pool. Okay, there's a follow-on. I mean, like R1 equals remote, R2 equals remote, R1.sendLine, R2.sendLine. Those would fire almost at the same time. Okay, so this is true. This is a way to do it because I/O within Linux is inherently asynchronous. So due to the fact that these R1, R2.send lines are technically happening asynchronously, you could still get things to be concurrent. So just to quickly run down that line of thought, you could, for instance, do like pwn.remote.sendLine, and this is going to be something I'm going to get to also in the future. This times like 10,000, and we could do this back to back, and these would be happening. Almost certainly there would be overlap, and this would be happening concurrently, even though we're executing it sequentially within our script. We would actually probably be getting some concurrency here because of the asynchronous nature of this. But I guess I'm just choosing to, even on the scripting side, get things happening concurrently because, I mean, I don't want to think about basically if this server is going to finish processing all 10,000 login requests before this happens. I guess I just want to really make sure these are happening same time or more likely to be happening at the same time. So that's kind of why I'm going down this route. It's possible it doesn't matter, but that's why. So I think it's submit. Do I submit? Why do I not have like a function? elif func in quarks. Passing fn as a keyword argument is deprecated. Why is this so weird looking? Why is it just taking args and quarks? Why can't you just be like a normal person and name what your stuff is? Like, why, whoever, this is disgusting. This is not how we should be writing code. There is no reason that buffer is read only. How do I make it not read? There should be a self and a fn. This is terrible. Okay, whatever. So the first thing we're going to be passing is a function. So let's just say work. And within this, what we're going to do is like this. Okay. And what we can do is we can pass this pool.submit work. Okay, and then let's just do for in range num connections. This pool submit work. What are these things called? I get something back. Return F. What is F? It's a future. Who wrote this code? Why do we just have F and W? Why can't we call this future? Not good. Not good at all. This would not pass my code review. Submit future equals this. We'll do futures equals this. Futures append this. And basically what we're going to do is we're going to wait on these futures, which I assume is a thing we can do. Do we have waits? Def wait. Wait, is there a way to like wait for multiple? Probably if I read the documentation, this would be quicker than just reading through this code. Wait all. How do I wait for multiple? I mean, I guess I don't really care. We can just sequentially wait for them. Whatever, we'll just do that for now. There's probably a way to wait on all of them, but we'll just do for blah, for future in futures, future dot wait. Okay, let's see what this does. Something happened. Okay, we have these warnings. Let's get rid of those. Pwn context updates encoding equals Latin. Okay, we got rid of that. Future object has no attribute wait. I could have sworn I just saw wait. Future. Where base dot future. This thing. Object. Def. Repr. Running. Done. With self. Is this blocking? Turn true. Add done callback. Result. Exception. We should probably just read the docs. Set result. Set exception. Hold on. This executor thing. This is the base class. This is going to have our thing that's going to multi-wait. Shut down? No, it's not. Okay, let's read the docs. Python. Oh dear. Oh boy. Hopefully this... Did the stream just die? I hit the wrong sequence of things. Is the stream still here? I think it's still here. I see you. Okay. Hold on, let me just make sure that it doesn't look different. Wait, so did my stream just continue and show me log? Whatever. Okay. What do we want to do? Concurrent futures Python. Okay, what do the docs say? Here we go. Submit. Wait on future. Submit f.result. Future. Process pool. Done. Something's going to block on this thing being wait. Concurrent futures wait. FS. Is this multiple? Wait for future instances. Okay, this has to be it. dot wait. Okay, there's no example of this, but this must be it. Wrong thing. Concurrent futures wait futures. Sure, this is it. Okay. Sweet. We didn't have errors. This is very promising. And then let's say that we do remote.clean. And pull an info, stir length of this. Cool. Okay. Don't know why some of these are smaller. Maybe timing stuff went weird, but we can see that we have a skeleton script thing that seems to be doing what we want, which is cool. We all saw your password. Oh boy. The OBS is unstarring my password. That's terrifying. Maybe I should type my password backwards. Okay. So we've got this. Okay, so here is apparently this is how concurrent.futures works. So this is a template script that we could use to start doing things in parallel without using os.fork, which seems like it's going to make pwn.tools a bit happier because we're not going to have it in different processes, and when one of the processes exits, it tries to kill this. Cool. Okay. So hopefully this at least is starting to address how can we write a script that isn't terrible. Now, so something you'll notice is that I did this right here. And someone was, okay, so there's also a question, what does clean do again? Okay, so clean is basically the same exact thing as read, repeat, and I think in the case of clean, it's basically a timeout of this. In fact, we could see we do remote.clean, we jump to this. Yeah, it says default timeout 0.05. So I guess I had one more zero off. And we can see that in the source code, all it does is it returns self.receiveRepeat timeout. So they're basically synonymous. The general idea is that you would call clean if you don't really care about the contents. You're just trying to like clean out the buffer, whereas maybe you'd call receive repeat if you actually cared about the contents. Maybe that's kind of semantically the difference, but they're really just the same thing. I guess there's one distinction if timeout is 0, but that's not the default case. Okay. So in terms of increasing hit rates, this is probably the first and most important thing that I will recommend to you is, and actually in this case, it doesn't have to be sendline because we have the space after it. So basically, when we interact with this thing, and actually if I go back to here, quickly open tmux, we run the challenge, we netcat localhost 1337. If we send all at once login, space login, space login, space login, space login, we can see that's going to go through and process all of this stuff. And how do I want to show? There's another thing I want to show. strace dash strace ps aux, is it D? What was our ps aux for showing threads? H. ps aux H. We can see it doesn't show the thread ID. LSAL proc 4822 task 4832. 4832 cat proc, or no, we want, so this is our thread ID. If we do strace dash p this thing, sudo, because we're in practice mode, so we're blocked on a read. If we do login, 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 and we look at what happened with strace. Oh, I guess I'm a liar. Oh, it's because we disabled buffering. I was thinking that it was going to do just one read syscall, but that is not true. It is doing a bunch of read syscalls. The bare minimum, though, on the scripting side of things, we only have one write, which is something, potentially. psaux grep netcat, this thing, 4831, strace -p 4831, enter, sudo. Don't know why it's on that, but whatever. Login, 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 login. So on a minimum, if we look at this right here, we can see it's doing one write syscall to send it all at the same time, which is at least speeding up the client side of things. I guess it's not speeding up the server side of things. I have definitely noticed that in writing scripts, it is much better with these race conditions to do something like this, as opposed to do something like remote send login, maybe send line, because okay, so this and this basically do the same thing, but this on the client side of things only takes one syscall, whereas this takes 10,000 syscalls. And I don't have much evidence to show that this is better, but I have definitely noticed that while writing our solution script, something like this is much better. And if I had to guess, even if the server side still has to do all of these separate syscalls, it's less likely that it's going to be waiting on someone to actually send data for it to read. Like, it'll immediately be able to get this data, would be my best guess on that. It's going to be, yeah, that would probably be my guess, that as soon as it does that read syscall, even if it has to repeatedly do read syscalls, it's going to immediately get that data back, rather than potentially having to wait on the client to say something. So this helps a lot while writing scripts. The other thing, though, so before I had clean, read, repeat, they're basically the same thing. You need to be very careful about using something like remote.clean. So for instance, if for some reason we were back in this situation where we do remote.send line login, if you do remote clean right here, maybe you do like if pwn.college in, maybe we want to save this like this, in data pwn info data decode. Like, hey, is pwn.college in here? Like, let's print it if it is, and basically we've detected that we've won. If you're constantly spamming this clean, this is terrible, because we saw that there's this timeout of 0.05, and we said that this is the equivalent of the read repeat. It's going to continuously attempt to receive data for 0.05 seconds, which is a long time in the context of these race conditions. That means at a minimum, you would be sending login, and then you would be waiting 0.05 seconds before you sent login again. In the context of syscalls, this is like thousands, it's several orders of magnitude longer that you would be waiting between every single iteration and sending another login attempt. Don't do this, because your race is never going to succeed if you're waiting several orders of magnitude every single time you send login, and you're trying to like just barely squeeze into this little tiny gap. If you're waiting 10,000 times how long these syscalls are taking, your gap, you're never gonna align. But what does work, because I mean at some point you need to receive some data in order to see if you've won. If instead you do a bunch of logins and then you receive, right? Now we have a chance to win this race with 10,000 attempts, and then we're checking to see if we won. Don't check every single time if you won. There's no point. In fact, there's not just no point. it's going to make your race never succeed. Just go through 10,000 attempts and then check to see if you won. Those kind of 2 tips are something that I've noticed in a lot of people's solution scripts, and it's not good. It definitely makes things, I mean, it just makes your race not succeed. Okay. One instance of work running will result in server executing login sequentially right. Yeah, so if we had num connections equal to 1, like we would never be able to win a race condition. I mean, in this case, we're not actually scripting for a race condition. But correct, you're definitely going to need multiple. Well, you don't necessarily need multiple concurrent connections. In theory, we could do things sequentially and have the asynchronous behavior account for the concurrency. But yeah, I mean, yeah, this is just going to do 10,000 back-to-back logins. Whereas if we bump this up to 2, we would have 2 threads concurrently doing logins. Now, obviously, in the case of this isn't how you win the race. There's more to the story, which we kind of talked about at a high level in IDA. But these are definitely the biggest things I've noticed that help a lot and that people haven't necessarily done. Doing 10,000 logins all at the same time, effectively, at least from the client's perspective, and then check to see if you won after you've done a bunch of attempts. What if running login again after correctly exploiting the race condition will undo your work? How can you stop once you race condition properly? So for instance, so probably your script is going to look something like this. And we're not going to go through the exact details, but let's just pretend that what you're doing is, well, let's actually parameterize this instead. So let's make some nice, cleaner code. Let's say that this takes a parameter, and that parameter is going to be what's it going to be? It's going to be our command. And what we're going to do is we're going to do f command times 10,000. And let's say that, I don't know, for some reason, maybe this isn't the most, how do we want to do this? I don't know. We're not really setting up ourselves very well here. Let's just kind of hard code some things. Let's just say that we're willing to do up to 8 things. So that, in case anyone's not clear about this number right here, this 8, this is in the context of this process pool executor, how many processes Python is allowed to use, because in theory, this is like this pool thing and you're going to be submitting work and waiting for results and then submitting more work. And this is basically saying, hey, we can have at most 8 processes executing at the same time. Something to keep in mind. So for instance, though, if we do work and we do like login, and then maybe we do logouts, and we do, what's the other command? Win oft. This. Win oft. So let's just say we did something like this, and maybe this is actually a solution that would work, maybe it's not. There was a question about what if running login again after correctly exploiting the race condition will undo your work? How can you stop once you race condition properly? So like I was talking about is we're going to do like 10,000 attempts and then check to see if we succeeded. And you can't necessarily always do this depending on your race condition. Maybe there's no way for you to check that you've succeeded, and that instead maybe once you win your race condition, you need to do more work after that. And you might see this sort of concept will be explored more in Toddler 2, that you need to win your race condition, but once you win your race condition, you're not done. Like you don't just suddenly have the flag. Like you're just getting started once you've won your race condition. it's very helpful to see if you, so speaking towards toddler 2, it's very helpful to be able to do a bunch of attempts, and then after doing all of those attempts, if you can set up your race in a way where you won't undo your work, basically, like you're talking about, that we're not going to basically break our race condition success progress thing. I lost my train of thought. Yeah, so there's this issue of if we're going to do 10,000 attempts, and then basically we want to be able to check to see if one of those attempts succeeded without also making it so that future attempts undo us succeeding. And in this case, it works just fine, right? Because what we can do here is we can do data equals remote.clean, and if one of these happens to give us the flag, so if pwn.college in data pwn info data decode or whatever, and then here maybe we also just like exit, like we're done, right? We've found the flag, we're done, we can give up. But so this is something that could work here, because in theory the flag will just pop out and there's not more stuff to do. But if you do have more stuff to do, hopefully you can set up your race condition in a way where you're not going to be undoing your work. And if you can't, then now you can't do these 10,000 back-to-back like you're talking about. I don't know. It's hard to talk about this generally. It's very dependent on the target and what your sort of race condition is. Yeah, basically. We'll kind of get to that, I guess, in toddler 2. It's definitely a nice thing, though, if you can do 10,000 attempts, and once you succeed, future attempts don't break your success, because you might have to do more stuff after that race condition success. Okay. But yeah, in this case, yeah, okay. Doesn't the global interpreter lock interfere when using threads? Yeah, so in this case, we're using the process pool executor, which is going to create new processes, and each Python process has its own global interpreter, so that you're not bounded by that lock. If instead we did a thread pool executor, I think is probably what it is. Yeah, we would have that issue, which is why in Python, just don't bother with threads. They're no good. No good. I mean, there are cases where if you have an IO bound activity, the global interpreter lock's not necessarily an issue, blah, 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 blah. In that case, just use async. It's better. Yeah, just use processes here. Actually, this is pretty IO bound. There's a pretty good chance you actually could use thread pool here, but whatever. Don't worry about it. Yeah, 9.1, you need to call something like win auth after a successful race condition. Okay, so this is interesting, right? Like, so you might be tempted to write, in this case, a solution where you're doing log in, log out, and maybe you're intertwining these in a way where you're trying to win this win condition where suddenly your credentials are -1. And now you're ready after that. Let's call win auth now, because now we're finally -1. Let's do win auth and win. But this is kind of the wrong mindset with race conditions. You don't need to wait until you've succeeded to assume that you've succeeded. Certainly not in the context of this challenge. What happens if you just kind of add in another thread that just assumes that once you've succeeded, I want to do this work? And you kind of race that against the rest of your race condition. So kind of maybe like a dual prong race condition in some sense, right? Like we've got this race where we're trying to make our credentials be -1, and we're kind of forcing within our solution script this race of, okay, well, once it's -1, we need to call win oft. Just do it all at the same time. Yeah. So, because you're right, if we just were waiting for -1 and then we call win oft, this would be much harder. We couldn't do this because as we continue to call log in and log out, we're going to undo our progress like you're talking about. But in the context of this challenge, we can just assume we've succeeded and keep going. Just more races, more concurrency, more do everything. Yeah. So that's kind of an approach there. Okay, so there's a question. Was filling the pipe an unintended solution then for 7? So honestly, it's really interesting that people discovered this idea of abusing pipes for these race conditions. And I wonder if you, I'm not entirely sure if people have decided this or if it's true that you can use pipes and actually not have to deal with race conditions at all. Like if you can just pipe your way into victory for a lot of these challenges and that there's not a race. Either way, no, it is not intended. It's very interesting and creative solution though. So the pipe exploit is basically, and don't really want to be talking about unintended solutions because, well, it's whatever. The idea is at some point, where's IDA? Let's do this. In this CD project CTF pwn.college IDA baby race level 8. I think the basic idea would be that if you don't have access to these pauses, which are obviously a way to do these raise conditions without having to actually worry about timing stuff, like basically with these pauses, you can have 100% success rate. I think you can have 100% success rate on a lot of these challenges though, even without these pauses. If you have messages like, which would be a good one? Like, okay, so if we want this pause, and if I'm not sure if the .1 version has these rights or not, but if for instance it does, you could set it up so that where this is going to write to is going to fill up and that it can't write anymore, and that basically it's going to block here. If you can make it block here, now we have the exact same effect of pause. And you could do this potentially with pipes in a very creative way, that you can make it so that the pipe is filled with data. It can't write any more data. So it's blocked until it can write more data. Then you can like slowly pull data out and allow it to do that. And basically you can recreate the pause mechanic in the non.0 versions. It's pretty cool. But definitely not intended. And maybe, I don't know, maybe we'll do something about that. Maybe we won't. Pipe exploit sending all the bytes before the /n that actually triggers the code to continue, and send /n over all connections simultaneously. Well, that's also an interesting idea. I don't think that's what it is. That is an interesting idea. I'm not sure if you could actually, because so you're talking about basically if we do like remote send command and we don't have a space at the end, and then we send the space on all of them at the same time, like that would kind of give us more control. The issue though is that I think this is really useful to be able to send all of it at once. And in this case, if you did that, you'd only be able to send one command at a time. But I mean, in theory, you could spin up like I don't know, someone was saying you could only have 128 connections, but if that's not true, if you could have thousands, in theory, you could spin up thousands of connections. And get a bunch of commands prepped and then send the space or new line on all of them at the same time. You could do something like that. Maybe that'll be useful. Not entirely sure. There's probably all sorts of ideas, though, related to this. How much does pwn.college servers cost? You know, this is a yawn question. Whatever Google Cloud charges for 48 cores with 1 terabyte SSDs with, I don't know, how much RAM do we have? With 48 gigs of memory. I don't know. However much that costs. It's probably quite a bit. But we have a local server that's basically the same setup that I just haven't had time yet to transfer all of this stuff to. And it just hasn't been a good opportunity to do that yet. We do have a local server to transfer that to, though. We have a large cloud budget, though, but we also have like this crazy $1 million supercomputer that we're eventually going to transfer pwn.college to. Okay. Yeah, it's all the Twitch ads that are paying for it. Do you guys actually get Twitch ads when we're not partnered or whatever the other partnered is? I assume there's no ads for us because I think Twitch is like, if the creator's not getting money, then we're not going to show ads or something cool like that. I don't think YouTube has the same policy. I think you guys might get ads on YouTube if you don't have an ad blocker, but just use an ad blocker. Hopefully that's not a banned thing to say on Twitch. But yeah, this is all... Yeah. Okay, are there any final questions before I start wrapping up the office hours? Hopefully you see this as kind of a useful template for how you can do concurrent programming that we kind of figured out on the fly. Never had an ad on here. Well, that's cool. I thought you had a deal with the chicken farmers. Yeah, we do. That's why we sponsor them at the end of the stream. Can I get help on 15.1? Is that the last level of baby mem? I assume. I can't go too deep into it, but I can offer some advice. I mean, it's kind of similar to this setup where, you know, we have this like server thing. Let's see here, 15.1. I'm trying to remember how that compared. I know what 15.1 is. I'm trying to remember what 14.1 is, though. 15. So the simplest advice I would offer if you haven't quite gotten there is, oh, but I have trouble brute forcing the canary. Okay, that is not where I would expect someone to get tripped up. Yeah, there's probably something wrong with your script if you're not getting the canary. Does 14.1 also have a canary? Because I would expect that you would get the canary on 15.1 in the exact same way. I think 14.1... is 14.1 have a challenge function, but 15.1 not have a challenge function? Is that what it is? It's definitely 15.1 is TCP. I think 14.1, though, is also TCP. But I think 15.1 doesn't have challenge. But I think 14.1 does have challenge, right? That's the difference between the two. Hold on, let's quickly take a look here. 14.1. I don't think 14 was TCP. Oh, I might be thinking of ROP. Yeah. Because the stack. Oh, yeah, there's not a TCP, non-TCP. Not able to get the canary. Is 15.1 the only baby mem level with TCP? Let's see here. Netcat localhost 1337. Okay. Continue. Oh, we're not in the right thing anymore. 133. Attach 133. Okay, so now so we have a challenge function. The goal you're saying is to get a canary. You have to specify a payload size and then probably send a payload. I mean, if we go up to the challenge stack frame and xgx rbp, that would be our saved base pointer, saved instruction pointer. Maybe our canary. That is our canary. So somehow we have to get to here. We're currently, I mean, I'm imagining it's going to allow us to overflow this thing, right? So I can't go too in depth on the solution, especially since it's the last level of a module. So I would expect your script, the first byte it's going to leak out is going to be this null byte. Maybe if we want to print this without endianness, 8bx rbp minus 8. So the first thing you're going to leak out is definitely this null byte. But in the case of this, right, the next thing we would leak out is like a C9 and then a 1A. If you're leaking out null byte, null byte, null byte, I mean, I don't know, I would potentially add like a bunch of pwn.pauses or something to your script if you need that. / use pwn gdb debug and watch your script send data, see how that data overflows your canary. And I don't know, yeah, I would figure out how to use GDB to debug this. It's not... Yeah, I don't know what else to say about that. Other than watch your script execute and use GDB alongside, and somewhere your script is diverging from what you think is happening, and that's what you're going to use GDB to spot. And just, yeah, you need to watch memory, see how your overflow is interacting with this stuff. Honestly, just showing how to attach GDB helps. Okay, we can do that real quick. Okay, let's see here. Let's do... Okay, let's do x2.py. Import pwn. This is not what I want. Emacs x2.py. Import pwn. With pwn process. Challenge baby mem level 15.1. Set UID equals false as process. And then with pwn.remote, hold on, and then also pwn context update coding equals Latin with pwn.remote localhost 1337 as remote. We're gonna send after payload size. Let's just send 256 or I don't know, 512. 512. Send line after. We do write line. I like write more than send. Write line after. Remote dot read line or queen. Let's start with this and see what is currently happening with this script. Okay. Python x2.py. Send your payload up to 512 bytes. Okay, that's kind of what we would expect. Why is this getting weird? Exit. Reset. Do not want this window. Please go away. Okay. So something like this. And if we want to attach to this now, what we would do is we would do pwn Gdb Attach Process. This is actually slightly tricky. This is not the process. Huh. Hold on. I know that we have this installed. Is there a way to get all of the processes? PIDs? So now we need to get this PID. Okay, good enough. Do we need to specify that stuff? We probably don't. Don't believe them. Process iter list. Cool. P for P in if p.name equals starts with challenge This is actually a function? Who wrote this library? That's insane. Okay. This is probably how we can get ready to get a PID. Basically what I'm going to do is I'm going to grab all of the processes that start with /challenge, grab the PID of it, sort it, take the last one, and is it sorted? Yeah, sorted. And we're going to assume that that's the process we should attach to. Hopefully, Gdb Attach takes a PID. Okay, let's do that. Somehow we need to know who to attach to, and fortunately, based on how this challenge is set up, we're forking, and yeah. proc.pid of p proc.pid of but we don't know. I'm kind of confused by that. Hold on. PID equals this. Let's see if this works. Python x3.py. Okay, we need to import psutil. The issue is that we don't have an instance of the process of the forked process, right? Process is going to fork, and it's going to be a different PID that we want to attach to. We want to attach to the child, unless I'm missing something. Index out of range. Hold on. Pwn info psutil process iter list this repr. At this point, oh, it's just called that. Okay. PID of get PIDs of target. Wait, are you saying that it's going to understand forks? PID of pwn proc PID of. Okay, hold on. Whoops, wrong thing. Let's see. Pwn info pwn proc PID of process. Hmm. 2327. But that's also what the PID. I don't think this is giving us children PIDs. I don't know why. It says you can give it a remote though. Hold on. Let's see. Highly skeptical of this. How this would work. Unless it's doing the exact same thing I'm doing. We will verify that just in case if you pass remote to this, that it doesn't somehow find the other side. 2384. Hold on. Maybe it is. Repr PID. Baby num level 15.1. 5. Int object not whatever. Why? Stop PID not a function, but not dot name is. People writing libraries like it's not a Python library. Very sad. Oh, 2543. Wait, it found it. It's actually following a remote to the other side. This is insane. Well, that's cool. Huh. Okay, well, that means this stuff is all irrelevant. Cool. This. Moral of the story. Except I don't think... Oh, wait, maybe it actually is. It just didn't find a terminal. So if we run this from tmux and python x2.py, don't know how to attach that. Did we not give it 0? Oops, emacs x2.py. This is a list. We need to make it not be a list. We'll just take the first thing. Oh boy, now I'm using Emacs and tmux together. This is not where we want to be. Not a good feeling at all. What is happening? Okay. Not permitted. I'm in practice. Could sudo this, maybe. Hold on though. Before we do that, if we're going to use sudo, we need to do sudo tmux. And then let's just do python x2.py. What happened? I can't quite see what's happening. Wait, I know what's happening. This, let's go here, emacs x2.py. And then pwn.pause. Basically, the script is exiting, and then it's killing everything, and it's just going away. x2.py. Okay, so this is how we can do it. So we're currently in read. We're in the child process. This is how we can set up pwn tools and GDB in this context. So for instance, what we could do is we could do remotes dot pwn info remotes dot clean. What is it sending us? Let's see. Send your payload. Resend after. Where did that go? Send your payload. Did we copy that? Sweet. So after this, let's say we send. We'll just send A's. We could do a cyclic pattern or something though. And we want to attach. And then let's say we want to pause so we can kind of prep ourselves here. And then we want to do this and then this. Okay, let's try this. So we run this. We're currently paused. We haven't sent our exploit yet, which means we have time to set up a GDB script. Alternatively, we could script our GDB script equals x8i challenge. We basically want to break somewhere over here, right? Challenge plus 286 before we're getting ready to check the canary. 286 equals break challenge plus 286. And yeah, let's just start with this. And let's send GDB script equals GDB script. Exit, enter, enter, run it again. Okay, so we have our breakpoint set. Let's continue. Oops. And we're currently paused. Let's hit enter. We hit this breakpoint. Okay, so we are about to pull this out. So if we look at our GX RBP minus 0x8, we're going to see it's A's. So if this was a cyclic pattern instead, you'd be able to see offset stuff. Basically, this is the general structure of how you could start using GDB with pwn tools and looking at all of this stuff. So to clarify, because there maybe were some subtle details that I didn't explicitly point out very well, we're in practice mode, which is going to allow us to arbitrarily GDB attach to stuff, which is kind of necessary here. In fact, since we're in practice mode and we're using sudo, we don't need this. I think because we're already running as root. I pointed at my screen, that doesn't matter. I'm using tmux, so I did, to clarify, I did sudo tmux because I'm in practice mode. Sudo tmux, that means now I'm running as root. I'm going to run my script as root as well, which is going to allow me to start arbitrarily attaching to processes. That is not what I wanted to run. I wanted to run x2. And so now I'm running as root. I'm running the script as root. I'm able to arbitrarily attach to processes. It's all good. So sudo tmux, what you want to do. And we're attaching, yeah, it's scripting, etc., etc., etc. We're using pauses. We want to make sure that basically if we didn't have these pauses here, everything is just going to, well, yeah, everything's going to immediately exit. We'll see. So if we do python x2.py, for instance, we see, oh, this is terrible. We can't GDB attach, miserable. The issue is that this script is exiting and then killing the process and then everything falls apart. We need some sort of like pwn.pause or something that's going to make the script not exit. And if we add that, everything is all good now. We're currently in the read. If we continue though, suddenly we're right where we set our breakpoint in this GDB script. Okay, so this is the general structure. Hopefully that'll help you start debugging your 15.1 solution. Definitely very useful to be able to kind of walk through your script and GDB stuff at the exact same time. All right, I am going to wrap up this office hours. Thank you everyone for joining me, and see you all in the extended Q&A tomorrow. All right, see ya.